Okay, we're going to look at graphs of transformations. Order of operations. Okay, so let's take this down as a note to get going. Graphs of transformations are often presented in questions with multiple transformations. These should be carried out one step at a time, using the rules of order of operations. Okay, now in brackets what I'm going to put there is you might consider that to be BODMAS. Okay, now for example, you've got f of x and you draw f of x plus 2. Okay, so that's telling you to move the thing up by 2 units. Okay, now that's just a single transformation, but then imagine I said, well, what about minus f of x plus 2? Well, there's two transformations there. There's this one, which is a reflection across the x-axis, and then you move it up 2 units. Now the question is, what do you do first? Do you move it up 2 first, or do you do the reflection first? Well, that's what we're going to discuss, but you follow the rules of operations. BODMAS, remember BODMAS are that you would prioritise brackets, and then division, multiplication, and addition, subtraction. Okay, best explained by doing a few examples. So let's try an example 1. Okay, so example 1, and let's say we've got this. So you've got a curve that goes through 0, 5, and it also goes through 6, minus 3. Now what we're going to do is, well, first of all, call that y equals f of x. We're going to now draw y equals minus f of x plus 3. Okay, now the minus f of x, well, what does that really mean? That means that you're doing minus 1 times f of x plus 3. So there's two operations there. The first operation is the minus 1 times, and then the second operation is the plus. So what do we do first? Well, rules of operations, BODMAS would tell me to do the times first. So the minus 1 times bit is the first thing that I'm going to do, which is what? That's a flip across the x-axis. That's a reflection across the x-axis. What's the next thing I do? Well, after that, I then move the thing up by 3 units. So the minus 1 times, I would times before I add. So the minus 1 times is the reflection across the x-axis. And then the plus 3 tells me to move the thing up 3 units. Let's do that. Okay, so there's the first bit. The first bit is the reflection across the x-axis. So what does that do? It inverts the y-coordinates and doesn't change the x-coordinates. So 0, 5 now goes through 0, minus 5, and 6, minus 3 now goes through 6, 3. And as you can see, that thing's been reflected, and it's like the x-axis is a mirror. Now what do I do next? I need to now move the thing up by 3 units. Okay, so there's the thing moved up by 3 units. Minus 5 up to minus 2, and 6 minus 3, 6, 3 rather, goes up to 6, 6. The thing's been shifted up by 6 units. So let's have our table of original points and our first images and our second images. Okay, so there's the original points. 0, 5 there, and 6 minus 3. It then gets reflected to there. 0, minus 5. We invert the y coordinates, and minus 3 becomes 3. Then we shift the thing up by 3 units. Minus 5 jumps up to minus 2, and 3 jumps up to 6. Final answer. Okay, next one. Here's my original curve. Y equals f of x, goes through 2 minus 2, minus 2, 5, 4, and 7, 0. And then I need to transform it. And again, there's multiple transformations here. There's the 2f of x, and then there's minus 5. Okay, so 2f of x, that's 2 times f of x. And then I've got a minus 5, so I've got a times and a subtract. I'm going to do the times bit first. So I'll do this transformation first, the 2 times, and then the take away 5 will move the thing down 5 units. Okay, so there we go, that's the 2f of x. What does that do? That stretches the thing vertically by a factor of 2. Minus 2 stretches down to minus 4. 0, 0 times 2 is still 0. 5, 4 stretches up to 5, 8. So it's the y coordinates that are getting doubled here, and 7, 0 will stay at some 0 since 7 times 0 times 2 is still 0. Okay, and then my next move is to move the thing down by 5 units. So 8 will come down to a y coordinate of 3. Minus 4 will come down to a y coordinate of minus 9. A 0 y coordinate will come down to minus 5, and that will happen here as well. Okay, there, so there's the new curve. Let's now put on the original points and the two sets of images. Okay, so the original points then were minus 2, and then the origin 0, 0, and then 5, 4. Okay, our first set of images given by the curve that's in red was minus 2, minus 4. And then 0, 0. And then 5, 8. And then finally the curve in green, which had been moved down 5 units, so minus 2, minus 4 down to minus 2, minus 9, 0, 0 down to 0, minus 5. Notice how I annotate the curves as I go. And then 7, 0 down to 7, minus 5. Okay, so final one we're going to look at. We've got the curve that goes through minus 2, 0, 2, minus 4, and then 4, 9. Okay. So we to now draw minus f of 2x minus 1. Now this time there's 3 transformations going on. There's the f of kx bit in the bracket. What does that mean again? There's then the minus 1 times bit, and then there's minus 1 outside the bracket. Okay, so the first thing that we need to do is the bit that's inside the bracket. Now that's f of k of x, so what does that do? That then squashes, it compresses the thing horizontally. So the first one that I'm going to draw, and I'm going to put that in green, will compress the thing horizontally. So that basically squashes in the x coordinates by a factor of, well, on this occasion it's 2. So that squashes the minus 2 into minus 1. It then squashes the 2 into 1. Notice it doesn't have any impact on the y coordinates. It then squashes the 4 into 2. So then I mark that in. Okay, so minus 2, 0 is now at minus 1, 0. Instead of 2 minus 4, it's now 1 minus 4. And then instead of 4, 9, it squashes into 2, 9. Okay, my next move then is to do the minus 1 times bit, so that's the reflection across the x-axis. Okay, so minus 1, 0, well that will still reflect to minus 1, 0. 1 minus 4 will now reflect to 1, 4. And then 2, 9 will now reflect to 2, minus 9. Okay, and let's just fill in the points of that then. So 1 minus 4 now reflects to 1, 4, 2 minus 9 now down to 2 minus 9. And my final move then is to move the thing down by 1 unit. Okay, so minus 1, 0 now moves down to minus 1, 1, 4 down to 1, 3. And then 2 minus 9 down to 2 minus 10. And let's just fill in our points here, it's getting a wee bit cluttered. Okay, so let's put these points then in green. So minus 1, 0 down to minus 1, 1. One 4 down to 1, 3. And 2 minus 9 down to 2 minus 10. And you can finish it off by putting in the table with your original points and the 3 sets of images. Okay, so you're going to have a go at these two. Okay, so you've got y equals f of x. As shown, you need to draw y equals f of x plus 2 minus 3. So you're going to have to do the bracket first, I would suggest, and then think about the minus 3. And then think about what this means in the bracket. That's horizontal movement, and then vertical movement down. Okay, then example 2, you're given y equals f of x, and you need to draw minus f of x minus 4. So minus 1 times f of x minus 4. Maybe you need to follow the rules of BODMAS. Set your table up with the original points and the first and the second set of images. You're not going to have more than 2 sets of images of these questions. 2 transformations there and 2 transformations there.